Nanti dia nak bincang ni. Okey,
Okay. So, we press on the mode to do the setting lah.
Okay.
Change the mode, we push the mode.
Yes. So, the current, this measurement,
This one measurement, ada set current.
THD,
Also measurement.
set cost.
Okay.
This is where we need to set the desired power factor.
Okey.
Yeah. Let's program.
Example, we set for 0.90 lah.
Yeah.
And then,
Program. Blink. Set. Okay. Program.
Mode, program, and then select.
Mode is to switch in between all these
Selection lah.
selection. Yeah.
Then
The CK ratio. ATC is ATC is auto mode. Never mind. We can just have a look. 1.2. This need, if you want to set value, we need to know the smallest bar of the.
this one lah.
Okey, 2.5 lah.
Yeah.
Okay.
Then we do some calculation on. There's a formula
Oh,
over
within the
here.
table.
Yeah. Yeah.
Okey.
So
Example, you set for
let's say the smallest that you have is a 15K bar. The CK ratio is
0.13 CK lah.
yeah, it's a 2.88 multiplied by the K bar divided by watt times M.
Okay.
Yeah.
Then
And
you got
there's a chart over here.
to 0.13.
Yeah. Okay, then we go back to the ATC. Program. Sensitivity. Okay. Okay, sensitivity. So for the sensitivity here is the 45. This is in terms of the second. Is how fast is the speed of the switching.
Oh.
Yeah. And reconnection time is whenever there's a step out. How long does it take to reconnect back on the same step?
Okay, the same capacitor bank.
Yeah, the same capacitor bank. So the next would be the Richter step. Okay. So the Richter step is where you set the let's say the first 1, 2, they are the same. And we set the
You need to set the CK first. Set the CK first.
set the CK. If you want to
Before you
set
do step, you need to set the CK. Example 0.13, you set for 0.13.
Yang dah pakai kuku. Dah bocor.
Ni aja dah itu bila.
you want to set the CK.
Sebab dia nak reset betulkan PCB.
CK. Let's set the CK ratio.
Kuku dia lagi panjang daripada jari.
Terus pening on tak buka je isu.
It's too small.
0.13. Example,
0.13.
you just set it for 0.13.
So small.
Itu untuk berapa? 15K pak?
CK ni CK.
Kita nak select 2.5?
Berapa K bar ni?
If let's say, no, there's for the 2 point, just
Dia
as
calculation tu.
yeah, this is the calculation. This is the chart that we can refer to lah. Please follow the measuring CT ratio. Okay, if let's say our first step is 2.5 kW, it should have the CK ratio over here.
How many kejap lah? 2.5 for
2.5 kW, the CK ratio for if let's say our
Habis ni 600.
600 kita punya
We
CT.
don't have lah.
ada.
Okay, tak apa-apa kan. We go for the nearest lah.
The nearest, okay, the nearest is let's say 0.03.
Okay, 0.03.
Only 2.5 lah.
CT ratio at the main side lah.
Yeah.
The capacitor bank ada CT ke?
Ada?
Ada.
Oh, CT ratio, CT cap bank lah.
Cuba tengok dia punya layout drawing.
Okay.
Dalam tu ada? Dalam tu.
Yes.
Okay, sorry.
So you need to have a
Ni mana?
Oh, ni.
yeah. So where we connect to is here.
So the red line. Red
Yeah.
face. Face line over here.
This fan, yeah. To here, cap.
Tu?
This cap.
CT.
Yeah, CD cable. Where does it come from? It's from here.
Oh, dia CT dia dekat tengah.
Yeah. Because we take the common load.
Okay. Okay, noted. Okay, next. After we set the CK ratio,
Let's say we take the nearest one.
the nearest mana? Okay, right.
Berapa CT dia? Tadi?
Huh?
Berapa CT?
600.
600.
Normally the same with the SB punya sizing je.
The first step. See.
Okay, settle. So step 1 tu. Okay.
Let's go here. 001. Step.
Alamak, cuti budak ni. Sekolah dia cuti pula di sini ni. Cuti festival.
Oh, Syah.
Malaysia.
Saya tak syok.
Not able to set
Melaka
this
ke
one.
federal?
Batam pergi kat semua Melaka.
Okay,
Sekolah dia.
jump to the switching program.
Palembang.
Okay. Lah.
So there are 4 types of switching program. One is auto. One is this is manual.
Dia tak ambil tu. Sebab dia nak buat cuti
This
ni
is a
lah.
fourth quadrant.
Pandai dia.
This is a rotation. So
Satu ni dia
the
suka
rotation,
sekolah,
the fourth quadrant is mainly for the if there is a solar installation.
Okay.
Yeah.
Oh, this one for solar installation.
Yes. To create
Function for FQR.
FQR fourth quadrant.
The normal lah, so you show
is
the...
to
That
prevent
means the board is sourced from solar.
no. We mean that whenever we have a solar installation in this switchboard, right, the power flow will against the city P1, P2.
Okay.
Yeah. Whenever, because for Capan they will only detect one flow from P1 to P2. When it detects the abnormal power flow from P2 to P1, so it will act havoc. You don't know how to justify. So when we switch to fourth quadrant, so it will know, okay, whenever there's an abnormal power flow, so it will not take any actions on that. Yeah.
Okay.
Yeah.
Ada tu kerja.
So this is
Mode auto.
sorry,
Auto mode.
let's say we have it on the manual. Okay. So how we
So how we want to do manual? So
up? This is under manual mode lah. But now
The red, that means when the indicator light is on, it's mean on the charging or discharge.
on charging.
Charging.
Yeah.
Charging the capacitor.
Yes.
So when the capacitor is discharged to the system, to the bus bar, Auto resistor lah.
Charge, I think it discharge to the resistor whenever they disconnected.
I mean, more not discharge. It's flow the power of reactive power
Yep.
to the system, power system,
Yeah.
to the load.
Whenever it's connected,
Okay.
whenever it's connected, it's already there's a rating
Ni tak
power.
ada load, ni tak ada
Yeah, to
load.
the load.
Okay, I mean, example lah, we have this board connected to the load,
Yeah.
and then we see the indicator light is on, red
Yes.
light lah, on lah.
Yeah.
It's mean charging.
Yeah.
So when is discharged, the capacitor
When is
Discharge.
it step out, you mean?
step out to the system lah. When it
When you will step out, okay, it will the CT will reflect, mean that the power factor that we see. Yeah. We need to set the desired
0.5 lah.
yeah. When it
we
reach,
detect less, recharge lah.
yes. When it
So
detect less,
the capacitor will remain charged lah.
yes.
Until it detect, it will discharge.
Yes.
Oh, so indicator light here it's been charging.
Yes. So this is under manual mode.
Okay, Andrew. So right now we have in charge position.
Yeah.
So is it okay we can we
Wait.
dismantle the capacitor?
We have to wait.
Or
Right now.
that time we have to wait lah.
Yeah. That time we have to
Okay.
wait. After we charge it.
5 minutes.
Yeah. About
5 to 10 minutes lah.
Yeah.
Okay. How to confirm To confirm the cap bank is fully discharged. We can use a multimeter to check, or
When it's charged.
after 10 minutes lah. After
Yeah.
10, you say after 10 minutes we left the cap bank to discharge.
Yeah.
So how do we going to double confirm?
Good question.
Let's say when we want to remove the the cap bank suddenly blow ke apa ke, you don't know lah.
To check whether.
How to check? Check the voltage or resistance. Maybe you can help. Is there any parameter you want to check?
Let me see. Let me think.
Let's say that right now we have already charged the capacity cap bank, isn't it? So after that we will left them to discharge lah. So how are we going to confirm before we dismantle the cap bank?
I'll have a try.
Remove
Then I'll
them.
get back to you in a while.
Okay,
I'll have a try. Then I'll get
because we want to teach our students kan. So they say, if we don't take that safe action, or maybe, but capacitor ni dia act as a source. They can act the power source to charge.
Okay, and then the alarm here. So we have gone through the switching program, harmonic THT limit, and then the alarm program here. So we have to refer to here.
Tapi kalau macam capacitor biasa, ni capacitor yang biasa tu kan, kita nak discharge cepat, kita short je kaki dia.
Betul?
Kita boleh tak buat macam
Dia
ni?
tak boleh, dia off tadi resistor tu boleh discharge. Dalam bilik
Betul lah,
resistor.
betul lah. Tapi kita nak confirm dia, kena measure lah. Kita kena,
Aku rasa nak kena confirm kau discharge
Sebab
reading
dia-
ke, pakai dicarut ke, pakai
dia
anti-roll
carut
ke.
apa dia punya tu, reading dia, kita nak tengok.
Semalam pun
Reading M lah.
dia suruh tunggu 5 minit kan.
Yalah 5 minit ke 10 minit, kita tak tahu ni. Kita student ni kan, kalau kita tersilap kan, kalau kita nak remove kan, dia punya tu kan. Yalah.
Double confirm.
Nak double
Tengok
confirm.
supply lah. Tapi aku rasa bisa discharge. Pakai anti-roll. Ambil kabel lah. Touch.
Buat pada cap bank tu.
Terminal lah.
Terminal dia?
bank.
Boleh lah macam tu.
Kita yang buat dia. Bukan dia buat kita.
Aku yang tu aku berani buat, yang besar ni aku seram sikit.
Sama je.
Pakai test slam kan.
Yalah.
Jadi kalau dia charge lampu kau hidup betul juga. Kita try. Tapi test pan pun boleh.
Yalah.
Test pan boleh rendah voltage dia.
Mau pegangnya bagi nak.
Walaupun dia lari sini je. Boleh kita try. Biasa tapi nak senang tunggu 5 minit. Tunggu 5 minit dulu.
10 minit kita.
Discharge lepas tu. Kan?
Banyak ke bilik ni biar.
Yalah, tu dia punya first tu, tapi Barang kita tak tahu, tak boleh percaya. Kau kena double confirm. Dah tak ada apa-apa kan.
Itu mati. Tak bajet.
So I switch on the first step. Charging the first step.
Okay. Tapi ni tak boleh buat ni lah terus discharge macam tu, tak boleh buat. Dia kena 5 minit 10 minit. Tu aku tengok beza dia. Kalau yang biasa tu kau boleh discharge terus, tak payah tunggu.
Saya rasa sini je.
Yang ni kau tak boleh. Kau kena tunggu. Oh, itu yang aku tengok macam
Dia besar sikit.
ha.
Tapi baru 10 kebab paling besar.
Tapi tak adalah
60 kebab je.
Ha.
Kalau buat memang main kat sini kan. Kat nombor tu.
Dia sini 440 capacitor
Yeah.
This one.
Yeah.
How we define the step of the capacitor bank? I mean from the 22.5 kW till the last step.
For the normally we design the steps, right? We start from the smallest step is we can get is 2.5, and up to the largest that I've seen is about 40 kW. If let's say the capacitor bank needs to be like 100 or 200, they parallel up the capacitors.
Oh, parallel also,
Yes.
I understand.
Yeah,
Summation of that one lah.
summation of that one. And then normally how we design is, let's say we start from 1 kW. The next need to be double it.
Okay.
Now double it. Let's say after
The minimum size for the capacitor bank?
well,
1 kW, we have 1 kW, 2
Yes,
kW.
yes.
Also have.
Yes. Depends on the manufacturer. If let's say this one we are using, of course, the smaller size is a 2.5.
Oh, 2.5.
If let's say the local brand Alcor, I'm not sure whether one of it is Alcor brand. The smallest is a 1 kW.
1 kW.
1.5 to 2.5. They have a very that is
small
normally
range.
for very small rating. Normally they use it for I use it for the indoor water project because their motor is not big, 2.2 kV.
Oh, your motor is not so too big ah.
Yeah, they want to have a fixed capacitor for that particular starter. So let's say 2.2, I give them a 1 kV
Okay, I
capacitor.
understand.
Yeah.
That's why they are need too small kebab. I don't understand. Okay. Yeah.
Okay, settle lah.
Yeah.
So far okay, settle the capacitor. Dah. Aku nak minta dia ni kejap. Check. So far for capacitor bank.
Okay, define for circuit breaker of capacitor bank.
Okay. Good. Yeah, I missed out that.
Apa?
Let's say a 2.5 kW. Okay. The breaker and the contactor need to be double up.
The value.
Double up the value. Let's say 2.5
KW.
10 kW lah.
Okay,
10
The
kW.
minimum M rating for the breaker
20
is
M.
20 M.
Okay.
Yeah. And the minimum
Double lah.
contactor sizing is a 20 M AC. Normal for switching contactor, they use AC6B.
Circuit breaker also 20 M.
Or you use if you use an AC3 contactor, it need to be 20 M.
20.
AC3.
Because normally when we see a contactor, right, there is a two rating. One is AC1 and AC3. AC1 is normally for those for the lighting control.
Yalah, yang tak bukan heavy duty punya lah. Light-lightnya.
So need to be double.
So AC3 for the heavy duty.
AC3 is normally for those motor starter.
Yalah.
And when you see,
Type
let's say
breaker
this,
lah, type A, type B, type C tu.
let's say for this one, they have two rating. AC1 it will be 20 M. AC3 is 9 M.
Oh, equivalent.
Yeah, equivalent.
Oh.
It's equivalent.
Their graph is different lah. Okay,
So
understand.
the breaker 20 M lah.
20 M as well.
Oh, okay.
Same with the capacity rating of contactor lah.
The type also type C punya lah.
No.
No.
For the circuit breaker, I think.
C-type. C-type isn't it? Normally lah.
And then for
For
summation
industrial-
of the circuit breaker, I mean this one, the bigger last one.
Summation of this one.
Dia bukan summation of the current, it's a range of power.
Let's say like
Cabang ni
the
yang
total
mana
bank-
yang critical je.
the total bank is, let's say this is 100 kW. The main breaker has to be 200. This one.
Okay, okay. Okay, alright. So for alarm and fan. So right now I see your fans already connected directly to the thermostat and the circuit breaker lah.
Yes.
And not controlling by the control from microcontroller. Yeah. How about the alarm here?
Okay, alarm here. Okay, alarm here you see LOL. LOL here is a current lower than 1% of rated value.
Oh, it will be display at that page lah. So
Yeah. So over here, let's say when it shows
Does alarm
stage-
happen?
Yeah.
Is there only indicator, any buzzer, something like that? Don't have ah?
No, it will just indicate here.
Oh, indicator is there.
LOI, LOL.
Yeah, LOL.
Normally we
The-
set
the
for
alarm
the
lah.
last two. Either alarm and fan.
Yeah.
Last step. So here we don't set any lah because we are already used for the 6 step. PFR 60 is for 6 step lah. We are already used.
What model do you use to have the
Right now, sometimes we bigger. PFR 14 or PFR 80. We have last 2 step we set for alarm and fan.
DLAP, right?
Also have micro.
Micro also have.
DLAP also have.
I see. Because I thought DLAP has another 2 terminals especially for the fan.
Oh, I'm not remember. Maybe that one.
Yeah.
But micro we have 2 last time we check set for
For the fan.
alarm and the fan.
Yeah.
But right now you are using the thermostat
Yeah.
for the fan. But alarm I don't think you are setting here lah. Okay, that's all lah.
Okay, settle.
Yes.
Okay,